Fractions. We deal with fractions in our everyday life. For example, when we wake up in the morning, we have so many minutes before we go back to bed that night. And those minutes are divided up into different segments of what we're doing: studying, attending class, commuting, going to work, taking care of our children, all sorts of things. Another example would be our paycheck. If we get a paycheck, it's divided up, and a fraction of it goes to pay for our housing and our utilities and childcare, birthday present for someone special. So we're used to dealing with fractions in our everyday life. Even when we cook some mashed potatoes, we put some out on different plates. Those mashed potatoes on the plates are a fraction of the whole pot of mashed potatoes. So we deal with fractions in our everyday life. We're always taking part of some whole. So let's look at how we look at this mathematically. Here's a representation of a fraction, and the number in the top is known as the numerator. This horizontal bar right here is known as the fraction bar, and it's also a symbol for division. Sometimes we just leave it as part over the whole rather than dividing 1 by 2. This would also mean 1 divided by 2. And then the number that's down is the denominator. So D for down and D for denominator. So a half is a fraction that we're familiar with. It's easy to estimate or calculate exactly the half of a given quantity usually. It's just something that you divide by 2. This type of fraction that I've written up here is what's known as a proper fraction. For a proper fraction, the numerator is less than the denominator. And that's often how we see fractions as written. Okay, now let's look at some examples of fractions. And the key to understanding fractions is to be really, really clear about what your denominator is. Because if we're going to make a connection between fractions and our everyday life, we've got to understand that the numerator is talking about some part, and the denominator is talking about the whole. Whatever that whole is, whether it's all of a paycheck, or the hours or minutes in a day, or how many slices are in a full pizza, this is going to be the whole. So you've got to think about what the whole is, because that's going to change depending on the situation. The denominator, or the whole of my paycheck, is going to be different than the denominator of how many slices are in a piece of cake or how many minutes are in a day. Those are going to be different values. So for every different situation, the whole is going to change. And so we just have to be really, really clear about what our whole is. All right, so I've decided to use some examples of different denominators, different parts of wholes, using money. So let's look first. I'm going to start with the smallest denomination here. I'm going to start with the $1 bill. Okay, so I'm going to consider a dollar bill to be a whole. So that will be my denominator. And I have one of them, so that would be my numerator. And we notice that this would actually simplify to 1. 1 divided by 1 would be 1 if we simplified it. We also notice that our numerator is equal to our denominator. And anytime that's the case, the fraction is going to simplify to 1. Because any number divided by itself, except for 0, is 1. Now let's look if I had $2. how would I express that in terms of a fraction? Well, my whole is still 1. I still have $1 bills, that's my whole. But now I have 2 of them. And again, we can simplify this down to 2, just taking our fraction bar to task. Now, what this example shows is a different type of fraction than a proper fraction. These are known as improper fractions. And these improper fractions occur whenever the numerator is greater than or equal to the denominator. So a lot of times we think about fractions being less than the whole. And often that's usually what we use fractions to discuss, part of a whole, where the part is going to be less than the whole. But in some cases, we are going to have fractions that are top-heavy or actually equal to 1. Okay, now let's continue a little example here. All right, so let's, instead of having $1, I have $5. And instead of considering this now as my part, I'm now going to consider this to be my whole. So what does that mean? Well, that means that $5 is now my denominator. And if I have $1, that's my part, so I have $1, this is my whole. I have a whole different fraction to describe this dollar compared to when my dollar was my whole. So we know that $1 is $1, and $1 is also 1/5 of a $5 bill. So I just really wanted you to think a lot about fractions and how they depend so much on the context. We have a dollar bill here, and it could be 1, or it could be a 5th, depending on what we're comparing it to. So if I had my $2 now, and then here's my $5 bill, which is my whole, this would now be 2/5. So the value of the dollars hasn't changed, it's just what I'm comparing it to. So I think one of the complicated things about fractions is the denominator can change. The whole can change depending on the context of what you're talking about. So you've got to be really, really clear about your understanding of what the denominator is. Now let's look at if I had a $10 bill. If I have a $10 bill, my $1 bill is now 1/10 of this. So my value isn't changing, but what I'm comparing it to is. So when I change what I compare my dollar bill to, then the fraction that describes it changes. And I forgot to write my 5. If I was looking at my $5 bill, that would be 5/5. And of course, we could simplify this to 1 because any number divided by itself is 1. And that makes sense because I define this as my whole. And if I have 1 whole, I have 1. Now let's look at these $2 compared to my 10. It's going to be 2 out of 10. And for those of you who are a little familiar with fractions, we can do what's known as simplify this, which we did here, even further. But I'm going to get to that in a different lecture. So I'm just going to leave it this way. And then if I look at my $5 bill compared to my 10, that's 5/10. So I haven't changed the value of this $5 bill. If I go into a store, they're not going to care what I'm comparing it to. It's $5. But if we're looking at it compared to something else, which is what we're doing with fractions, then what we compare it to is really, really important. If I was comparing that $5 bill to a $1 bill, that would simplify to 5. And usually this is what we're doing. Usually we're taking $1 bills and just considering them to be whole. And then, I don't get to hold these very often. Here's a $100 bill. Okay, so if I had a $100 bill, my 1 would be 1, oops, can't really. I don't think it matters. I don't think they care if they're upside down or not. You may care, sorry. But if I have a $100 bill and I have my $1 bill, then that's going to be 1/100. And if I had $2 or $5 or even $20 bill, these can be simplified. We'll look at how to do that later. But the point is that when you're dealing with fractions, it's so important to know what the denominator is. Because this is really kind of a comparison in a way. We're looking at some part to some whole. And unless you know what you're comparing or can make sense of it, it's going to be really, really hard to navigate through fractions. Okay, now let me just go over one thing. Any whole number actually can be expressed as a fraction. 5, which I originally wrote, if I wanted to express it as a fraction, 5/1. Because when we're talking about whole numbers, we're looking at whole numbers, 5 apples, 5 pennies. So each object is considered to be 1. So this is what our comparison is. So any whole number, any integer really, can be put over 1 and it doesn't change its value. Remember, if we divide anything by 1, it doesn't change the number's value. So 5 divided by 1 would still be 5. Now we know that this would simplify to 5. But what happens if there was a negative there? Well, we want to use our rules for dividing by negative numbers. Because basically the fraction bar is a division symbol. So this would simplify to -5 if you're asked to simplify it. It would be 5, that would be the fraction simplified, and there's one negative symbol, so that means my final answer, my quotient, is going to be negative. And it doesn't matter whether the negative symbol is in the denominator or the numerator or even in front. The fact remains there's only one negative symbol, which means my final answer is going to be negative. And likewise, if I had 2 negative signs, if I had 2 negative integers, my final answer would be positive. And I could have the negative in front like this. So I don't think you'll really see too much of the negative in front, but you may. And so remember that this negative would be part of this whole operation here, this division operation. And so when you have 2 negative integers or negative numbers involved in a division, your final answer is going to be positive.